Hello students, welcome to this lecture number 10 on chemical bonding and molecular structure. In the lecture number 9, we have discussed about the valence bond theory, and we understand from this theory that there is a overlapping of the atomic orbitals and due to which there is a formation of the covalent bond. In polyatomic molecules, this most important thing apart from the bonding is its shape. Because polyatomic molecule like NH3, like H2, like other methane, it will have different shape. Now, question is whether this valence bonds theory is able to predict all the shapes of these molecules. It is observed if we go by the simple atomic overlapping technique, then the shape of the molecules, of the polyatomic molecules, will not able to explain by these simple things. That is, when we overlap the atomic orbitals simply, that is the p orbital we overlap with the s with the s, or p with the p. At that time, what is going to happen? The bond angle is not going to be explained. It is the bond angle between the carbon, hydrogen, carbon and another carbon, hydrogen, carbon. It is the angle will be 109.5. 109 degree and 5 minutes. But actually, if we go from this orbital overlapping, simple orbital overlapping, what we find, it will comes around 90 degree. Even the overlapping between the s orbitals you can find, you cannot able to predict the bond angle. So from the simple overlapping technique, we cannot able to predict the shape of the molecule, polyatomic molecule. For that, Pauling has introduced a new concept to explain the shape of the molecule very accurately, that is the hybridization. So in this lecture, we are going to discuss this very important topic in the chemical bonding chapter, that is hybridization. The hybridization concept that is given by Pauling. And what is hybridization? Let us first understand. It is nothing but the mixing of the two or more atomic orbitals into themselves, and this atomic orbital will be the same atom and it will have the energy, slightly different energy. And so that it will redistribute itself, the energy will redistribute among these atomic orbitals, and they will going to form a new set of orbitals of equal numbers, and these orbitals is called the hybrid orbitals. And this intermixing of these atomic orbitals, we can say it is the hybridization. And the hybrid orbital will have the equal shape, equal size and equal strength. Some points we have to always remember in our mind when we are discussing this hybridization or answering some questions. That is several points. Number 1 points. So we can write here so this is the first point, that hybridization never happens to the isolated atom, only occur during the bonding. That is the first point that we have to remember. Second point, Second point, that is half-filled or fully filled orbitals or vacant orbitals can take part in hybridization. Third point, number of hybrid orbitals. Number of hybrid orbitals formed is equal to the number of atomic orbital mix. Suppose there is 2s orbital, one 2s orbital and 3 2p orbital has been mixed, atomic orbital has been mixed. Then it will going to produce the equal numbers of hybrid orbitals. That is 4 atomic orbitals have been mixed, 1 2s and 3 2p orbitals. So it will going to produce the 4 hybrid orbitals, and these 4 hybrid orbitals has been designated, has been named as sp3 hybrid orbitals. S means 1s, p3 matlab 3p means total 4 orbitals, and name is sp3 hybrid orbitals. Fourth point, that is again very important points. The hybrid orbitals is different from the other orbitals, atomic normal orbitals. It have the good capacity of overlapping with the other orbitals. So what is going to happen? The bond produced from these hybrid orbitals, we can write it, bond form from hybrid orbital So bond formed from the hybrid orbital is more stronger than the normal atomic orbitals. And fifth point, that is very important, the atomic hybrid orbital directed in space. So the fifth point is a very important point. Hybrid orbitals directed in space in a preferential direction, in a preferential way, so that there is a minimum repulsive force between them. And so this hybridization or hybrid orbitals arrangement will give a definite shape to these molecules. So from the hybridization we can able to say the shape of the molecule. So again a very important postulates that you can see all these points that is been from the hybridization. In hybridization you have to always remember that is hybridization never happens to the isolated atoms, only occurs during bonding. Half-filled, fully filled orbitals, vacant orbitals takes part in the hybridization, and number of hybrid orbitals form equal to the number of atomic orbitals forms, and bond forms from the hybrid orbitals is more stronger. And 5, the hybrid orbitals directed in space in a preferential specific direction, and it will going to give you the indication, prediction about the shape of the molecules. So there's 5 points that you need to understand. So you understand what is hybridization? Hybridization is basically the mixing of 2 or more atomic orbitals, and it will going to produce a hybrid orbitals that will have the same energy, same shape and same size. Okay, now we are going to understand the types of the hybridizations and the shape of the molecules. How we can able to say from this hybridization this shape of the molecules will be there. Only you know this hybridization, and from this we will be able to say the shape of the molecule. That we are going to understand now. sp hybridization. sp hybridization means we have mixed one s orbital plus one p orbital. So when this 1s and 1p orbital has been mixed, the shape of this molecule will be linear. because this hybrid orbital will align 180-degree angle to each other, so it will going to form a linear structure. So shape will be linear. Example of this BCl2, or you can say AgCl2, or are linear in structures. sp hybridization. Then sp2 hybridization. sp2 hybridization means 1s and 2p. 1s and 2p orbital. In this case, the shape of the molecule will be trigonal planar. Trigonal planar. Why it is trigonal planar? Because 3 bonds. 3 hybrid orbitals means there is a 3 bond, and these 3 bonds will hybrid orbitals will arrange itself with the 120 degree. So it will have the trigonal planar structure, and its example is BF3 or AlCl3. Okay. Then next is sp3 hybridization. sp3 hybridization means 1s orbital plus 3p orbital, and it will have the tetrahedral structure. Tetrahedral structure, and the example is CH4 NH4 plus. Then another example, now we are going to use dsp2 orbital. dsp orbital, in this case, the 1d orbital, the dx square minus y square plus 1s orbital, 1s orbital plus 2p orbital. In this case, shape will be square planar. Example of this is these molecules. This is a complex molecules. Then sp3d. sp3d, you can see in this case there is 1s 3p and 1d, and 1d here use the dz square orbital has been used. Here you can see it will having the 5 bonds, the 5 hybrids or hybrid orbitals. You can find that it will going to produce the trigonal bipyramidal. Trigonal bipyramidal structure, and here you can take the example PCl5 or PF5. Then another hybridization type of hybridization is this. Here 1s plus 1s plus 3p 2d, and d here z square and x square y square. In this case you can find the shape of the geometry will be octahedral. And here example is SF6. So from the hybridization, we can able to understand how we can able to predict the shape of the molecule. Total we have understand the 6 hybridization. Total we have under 6 hybridization. Another hybridization is there, that is sp3d3, where the 7 hybrid orbitals have been produced, and in this case you have the hybridization of sp3d3. Okay, so these are the type of hybridization that depends on the number of hybrids orbital produced and the shape of the atomic orbital used. Different atomic orbitals and number of atomic orbitals has been mixed. On the basis of that, this type has been classified. Now we are going to understand how do we predict the hybridization of a central atom, and from this central atom we will understand hybridization of the shape of the molecule. We are going to understand the prediction of hybridization and the shape of the molecule. That can be understood by this formula. This is a very important formula that we must remember. That is X. One physical quantity has been given X, and it is formula is this: D plus Ma minus C plus A. And we understand, let us understand this, what is V? V is the valence shell. Valence shell electrons at the central atom. Ma is number of monovalent atoms attached to the central atom. And C is the charge of the cation. Suppose the species is the cation. The cation that we want to understand what is the hybridization of this. Then charge of cation, and A is the charge of anion. Charge of anion when those are polyatomic species. From this we can able to predict the X. When X is 2 means it is sp hybridization. X is 3, it will be sp2. X is 4, it is sp3. X is 5, it is sp3d. When X is 6, it is sp3d2. When X is 7, it is sp3d3. So this is a very, very important thing. Now from this we want to predict the shape of the molecule. How we can able to predict the shape of the molecule, that we can understand. There is a 2 formulas. Number 1, 2 assumptions. Number 1, if the number of hybrid orbitals is equal to the number of atoms joined to the central atom. Number of atoms joined to the central atom. Then what is going to happen? Whatever the hybridization come, as per hybridization, the shape of the molecule will be this. Second point, if the number of molecules, number of atoms less than the hybrid orbitals. Hybrid orbitals then means hybrid orbitals. What it means? It means there is in the hybrid orbital there is a lone pair. So at that time this geometry will not be a regular geometry as per hybridization. As per hybridization, this geometry is not be going to there, and for that we have to understand. So that we are taking to understand these two very important things. We are taking some molecules to find out this hybridization. Okay, molecules and ions. Now we are going to understand how do we able to say the hybridization. First we will understand the hybridization of the central atom. Then from this hybridization, and we will be able to understand this. For this molecule, suppose molecule is CO2. So what will be the X? And we know for this carbon, it is having the electronic configuration 2 and 4. And the valence shell electrons is here 4. There is no monovalent atom is attached to the carbon atom. So it will be 0. There is no charge, no cation, no anion. So you can see its X is equal to 2. When X equal to 2, its hybridization will be sp hybridization, and number of lone pair you can see as there is a 2 oxygen atom joined to the carbon atom. Such a 2. So the number of atoms joined to the carbon atom, and this hybridization number of hybrid orbital is 2, so there will be no lone pair, 0. So this shape will be linear shape. Okay, and BF3 you can see what is the X. X is half. For boron we know it is having the electronic configuration is 2 and it is 3. So it is having the valence shell is electron is 3, and number of atom, monovalent atom. Here you can see it is a monovalent atom, fluid. So it is 3 and 0 plus 0. So it is 3. So here the hybridization will be sp2 hybridization, and number of bonds, number of atoms joined to this central atom is 3. Hybridized orbital is also 3, so it has no lone pair is 0, and its shape will be trigonal planar. Trigonal planar. Okay, NO3 minus. This is the anion. Suppose we are taking a cation also. Suppose this is cation also we will take. N we know it is having the 2 and 5. So it is having the valence electron 5 plus this will be 0, and here see it is anion. So for this anion you have to have 1. You have to add 1. This is the electron. So you will see this will have the hybridization is X equal to 3, means this will be sp2 hybridization, and here you can see number of hybrid orbitals and number of atoms joined, it is same, and for this there is the 0 lone pair, and it will have the trigonal planar as per the hybridization. Here you can see NH4. No, we are taking another example, that is suppose NH3. NH3 X is equal to, let us understand, that is half. Valence shell electron, valence shell it will have 5 plus H means 3. So it will total hybrid orbitals, hybrid X equal to 3, means this will have the sp3 hybridization. So here you can see that there is 4 hybrid orbitals, because sp3 means 4 hybrid orbitals. X stands for the number of hybrid orbitals. So the number of hybrid orbitals is 4, but here 3 hydrogen atom attached to the nitrogen. So here will be 1 lone pair. At that time, its geometry will be irregular. It will be trigonal pyramidal. Trigonal pyramidal. So in this way you can able to calculate, you can able to predict about the shape of the molecule. That is all for today's lecture. In this lecture we have understand a very important thing, that is hybridization. What is hybridization we understand, what are the points we have to remember, and also how do we able to predict the hybridization of the center molecule first, center atom first, then we will predict the shape of this molecule. Okay, that is all for today's lecture. Next lecture we will understand the molecular orbital theory. Till then, all the best and be best.